All right, guys, open up your notes packet to the 2.3 notes. Pause this video if you need to get there so that we can take some notes together. All right, today is really a pattern looking day, right? We're looking at some tables of values, X and Y are related. And down here, a linear relationship from a table means that there is an adding or a subtracting pattern for both X and Y. So we're trying to think of what are you adding all the time or what are you subtracting all the time. So if I look on this X column on this left side over here, what am I doing in order to get from 0 to 1 to 2 to 3? Well, I'm adding 1 each time. So plus 1, plus 1, plus 1. The X pattern is plus 1, right? All the time I'm adding 1. On the Y side in the right-hand column, what's going on over here? How do I get from 0 to 4 to 2 to 4 to 6? Well, in this case, I add 2 each time. 0 plus 2 makes 2, plus 2 makes 4, plus 2 makes 6. So as long as I have an X and a Y where I've got adding or subtracting both times, this is going to be something that is linear. All right, go ahead and pause the video here and look at this next one and try and figure out your pattern. All right, did you get this? It's plus 1 on both sides, the X's and the Y's, which also makes this linear. Notice I'm not so much looking at what the actual numbers are, I'm really looking for how do I get from one to the next. All right, this time we're going to pause it, do both of these guys on the bottom, see if you can figure out your patterns. All right, hopefully you made it this far with me. I actually want to talk about this Y side because you might have noticed that to get from 0 to 3, I can do plus 3, but then from 3 to 9, that's plus 6, and then from 9 to 27, that's plus 18, and that is not an adding pattern. So some of you may have also noticed that there's not an adding pattern for this one. It's more like a multiplying. 0 to 3 doesn't work, but from 3 to 9, I could times 3. And from 9 to 27, I could times 3. But 0 times 3 is not times 3, so there is no Y pattern at all. This guy is an example of what it means to be nonlinear. All right, so we're looking for an adding or a subtracting pattern on the top and bottom, or on the X's and Y's. All right, so let's look at some graphs down here on the bottom now. A relationship is linear if it makes a straight line on the graph. So, hey, this one's really easy. I should just be able to look. If it makes a straight line, that is linear. This guy is linear because look at that nice straight line we got going on here. This guy, nonlinear. Curvy line, doesn't count. Also nonlinear because it is a curvy line. This guy, we're back to linear because it is straight. Okay, so those are my two ideas, two big ideas that we've got going on here. If we've got adding or subtracting patterns, it's going to be linear. Or in other words, if you graph it and it makes a straight line, that's going to be linear. So let's flip this page over. On the back, we've got visitors to a carnival are invited to guess the number of beans that are in a jar. The person who guesses the correct number wins $300. If multiple people guess correctly, the prize will be divided evenly amongst them. And I want to underline that word divided because it says, what is the relationship between the number of people who guess correctly and the amount of money each person will receive? Well, first off, let's remember what our word problem words are. This word divided says that what we're doing is we're taking this 300 and we're dividing by how many people there are, or how many people want it. This is not an adding or subtracting pattern. This is a dividing pattern. So this is going to be non-linear. Adding or subtracting patterns are linear. Multiplying and dividing patterns are non-linear. So down here, I know it says you guys try, and you should, but I think we're going to do them together in this video. A student starts a new semester with $30 in their lunch account. Each lunch costs $2.50. What is the relationship between the number of school lunches purchased and the dollar amount in the account? So let's think this through for a second. She starts off with 30 bucks in her account, and then one day she goes off and she buys lunch and she loses $2.50. So that now she has $27.50 in her account. And then the next day she buys lunch again, so that's minus another $2.50 and she has $25. And then if she does that again, she has $23.50. Right? Each lunch costs $2.50, so we are subtracting $2.50 every single day. This is a subtracting pattern. This is going to be linear. Now, I do want to talk about this one because if you're thinking each lunch costs $2.50, if I wanted to think about how to write this as an equation, the total amount of money in her account is A. So I've got A equals. She starts off with $30, and then I'm losing $2.50 each, which means to multiply day, which is the number of lunches she's purchasing. So you may notice that here I have a subtracting and a multiplying pattern, but it's this subtracting bit that's making it linear. All right, adding and subtracting is linear. All right, the next one says the chef is pouring oil from a large jug into equal size bottles. The table shows the relationship between the number of bottles used and the volume of oil and fluid ounces in each bottle. How would you find out how many fluid ounces per bottle there are if there are more than 4 bottles? So basically, this is asking us, continue the pattern, describe the pattern, and let's figure out if it's linear or nonlinear. Well, the number of bottles, if I'm looking over here, is adding 1 each time, right? So if I wanted more than 4 bottles, I'm basically just asking to continue this pattern down. Let's figure out what it's doing on the y side, on the other side. 24 to 21 to 18 to 15, what is that doing? Well, that's minusing 3. So if I wanted more than 4 bottles, if I wanted to add another row down here and say, hey, what if I had 5 bottles? I could keep continuing this pattern, minus 3 again, it would be 12 ounces per bottle. And if I wanted to do that more, if I wanted to find out 6, I could continue this pattern again and it would be 9. Right? So how would you find out how many fluid ounces per bottle? This is keep subtracting 3. OZ is short for ounces. Don't ask me where they got the Z from. Right? So here I'm just describing what the pattern is. It's always minus 3 ounces, right? Minus 3 ounces, minus 3 ounces, minus 3 ounces every time you add another bottle to the stack. So I could do this indefinitely. I could do this until I hit 0 fluid ounces per bottle. It might take me a minute, but it's asking what is the pattern.